Our focus today is to get the mean and variance of the discrete random variable. Or meaning, our focus today is how do we compute the mean and variance of a discrete random variable. We have to remember that when we are going to compute for the mean and variance of the random variable, now we do have this working equation. So for the mean that is represented by mu, a symbol for mu, is equal to the summation of the product of the variable in its corresponding probability, or if that is not the probability, its corresponding weights. So when we're going to have the mean of the given discrete random variable, the probability in here could be considered to be a weight or a probability. Okay, it's a probability. Now, how are we going to compute? We are going to follow the same working equation. And what about the variance in here? The variance is actually the result of the summation of the difference of individual variable minus the computed mean raised to the second power, multiplied by its corresponding probability or weights. So after that one, we're going to add them all, summation. Okay? Summation of the product of these two, which is x minus mu, which is the mean, raised to the second power, multiplied by its corresponding probability. Now, after having now this product, because we have a lot of this one, we are going to get the summation. Now, what about the standard deviation? The standard deviation can be computed by just taking the square root of the variance. So, as you can see, the standard deviation is equal to the square root of the variance. Okay? So when we say variance, it is actually the square root of the standard deviation. Or vice versa, when we say standard deviation, that is actually the root of the variance. Okay? Now, mind you, when we are talking of the variance, we are actually talking of the dispersion of the data in a given set of data or gathered data in a survey. Shall we say a survey or gathered data from the grades? If we are talking of the grades, the data are composed of the grades. And what about this one? It is actually the distance from the mean of the given set of discrete random variable to a given calibration. So it is actually the distance. Now, to illustrate how to get the mean, variance, and standard deviation, we have to consider an illustrative example. So we have in here an illustrative example. It says in here, this table is actually a weather forecast. Weather forecast wherein it talks about the number of the typhoon in a month. So shall we say within a month there might be no typhoon at all. Okay? We have to consider our setting that in the Philippine setting there are two seasons that we have. So we have the rainy and we have the summertime. Okay, so there are months that there are no typhoons. So we have in here 0. Okay, with its corresponding probability that is the same as 0.15. Now another one, we might say that in a month there is only one typhoon that we experience. And what is the corresponding probability of that one? 0.35, or that is the same as 35%. Okay. Now what about the next? We have in here 2. Okay. In a month, there might be 2 typhoon. Okay, 2 typhoon that we experience, especially during the rainy season. Now, so that, as you can see, it has its corresponding probability, and which is the same as 30% or 0.30. Now, we have also in here, in a month, we experience 3 typhoon in a month, and the probability is the same as 0.10%. Now, again, in here, we have in here, 4 typhoon in a month with the corresponding probability of 0.13. Now, notice that, of course, when we are talking of the number of typhoons in a month, the 4 typhoons, 3 typhoons in a month is too much already. But this is a reality. This data are gathered from the from a weather forecast. Okay, so this is a reality. Only that its probability might be a lesser one, or in here with the 1 and 2, then it has a great probability that we really experience that one. That in a month we really experience a typhoon, maybe 2 or 1. Okay. In the summer, of course, you do not expect a typhoon. Okay, but looking at the weather today, it was already, there is a changes. Okay, so that as you can see in the southern Philippines, they are experiencing typhoon, they are experiencing flood, even though today is considered to be a summer. Okay, now it says in here, what is the mean average, or shall we say the mean average or weighted average of the typhoons that we really experience in a month? Okay, so that is the question. So the question is, what is the mean? Okay, what is the mean? Okay, so that is the question. Another one is, how are the typhoon scattered in a year? Okay, so they are being scattered. So that is actually the variance. So that is the same as the next one in here is the variance. The problem is variance. Okay, so how do we compute these things? Of course, we follow the same procedure, or we follow the dictate of our working equation. Now, what is our working equation? We get the product of the variable x and its corresponding probability. When we say x in here, this is actually the variable that we are talking. So the variable or the number of typhoons in our illustration. Okay? Now, what is P of x is equal to x? That is the same as the probability we have in here. Remember that when we are talking of the probability is presented into decimal, percent, or fraction. Now, in here, it is presented into decimal. Now, how do we compute now for the mean? Let's try to have. When we are going to have now the mean, we represented that one by using the mu symbol. Okay? So, what is our first variable? Okay, what is our first variable? That is the same as 0. So 0 multiplied by what? Its corresponding probability. So what is corresponding probability? 0.15. Okay, 0.15. Because we are talking of summation, and so that is the same as to add, plus another one that is the same as 1, which is our next variable. Next variable is the same as 1, multiplied by its corresponding probability, that is the same as 0.35, plus 1 multiplied by its corresponding probability, 0.35. Okay, 0.35. Now we have the next variable x. Okay, so that is the same as again plus, that is 2 multiplied by its corresponding variable, that is the same as 0. Corresponding probability, that is the same as 0.30. Okay, 0.30. So again, what is the next? That is the same as plus 3 multiplied by its corresponding probability, that is the same as 3 multiplied by 0.10. Okay, and of course, that is the last one, 4 multiplied by its corresponding probability. Okay, that is 0.10. So notice, that is the meaning of the summation. You multiply every variable to its corresponding probability, multiply every variable to its corresponding probability or weights, and then after that one, you add them. That is the meaning of that one. So multiply, add. So that is how to get the mean. And so, when you notice, when we are going to multiply that one and then add them, it will give you a result of the mean is actually 1.65. Okay? 1.65. So that is the mean of our problem. Meaning to say, if you notice this one, we do not just compute, we do not just present in here the number. We have to interpret what is the meaning of the mean, which is the same as 1.65. What is the meaning? That is actually the average. This one is actually the average mean of the typhoon we experience per month, okay? Per month. So that is the meaning of the mean. So meaning, in a month, we at least experience 1.65. Okay, 1.65. But you notice, when we are going to locate this one into the data between one typhoon to two typhoons. So you notice, it is within this part. Okay, it is. It tells you that more or less we experience at least two typhoon. Okay, two typhoon in a month, because we do not actually count a typhoon per proportion, or we do not count typhoon using fraction. So more or less, the 65, this 0.65 represent one typhoon. Okay, so that is the meaning. Now, another one is, what is the variance? What is the variance of the given problem? So the same, when we are going to have the variance, we make use of in here. Okay, so that is the variance is equal to the sum of this product. So how are we going to do that one? Notice that when we are going to use this formula without table, that is represented by saying, what is our variable? That is the same as 0. Okay? 0 minus what? Minus the computed mean. Minus the computed mean, that is 1.65. It says in here, this working equation is variable, individual variable, minus the computed mean, raised to the second power. And of course, multiplied by its corresponding probability. Corresponding probability of that variable. What did we use? 0. What is its corresponding probability? That is the same as 0.15. And 0.15. Now, we have another variable, so 1. So that is the same as plus. Okay? That is 1 minus, that is actually quantity 1 minus 1.65, which is the computed mean, and then raised to the second power, multiplied by its corresponding probability. What is that? 35, 0.35. That is the same as 0.35. Then, after that one, added with the next variable, 2, multiplied by 2 minus the mean. What is the computed mean? 1 minus 65, raised to the second power. And that is the same as multiplied by its corresponding probability, 0.30. Okay? 0.30. So it's so long. And then plus another, we have 3. Okay, 3 minus The mean, computed mean, 1.65. Okay? Raised to the second power multiplied by its corresponding probability, 0.10. Okay? So again, we still have, that is the same as 4. So plus, that is the same as 4 minus 1.65 raised to the second power multiplied by its corresponding probability, 0.10. So notice, what we follow is actually this one. Okay? So the difference of two number, that is the individual variable minus the computed mean raised to the second power and then multiplied by its corresponding probability. Now after that one, individual yan, so it says in here summation. So plus, okay? Plus the other process, the next process, 1 minus the mean raised to the second power multiplied by its corresponding probability. Okay? And again, that is to be added. So, same process. Okay, same process. So that is how you're going to compute for the variable or variance, or using the working equation. And so let's try to make a shortcut immediately. After multiplying, after subtracting them, raising them to the second power, multiplying to this one, and then adding again this one, subtracting this one, raised to the second power, multiplied by this one, and so on and so forth. Now, the variance now that we can have is, actually 1.33. Meaning, when we are talking of the variance, this value is actually the measure of the dispersion. The measure of the dispersion of the data or the typhoons. Okay? So this is the measure of the dispersion. Measure of the dispersion of typhoons. Typhoons we experience. Okay? So, ayan, that is how to compute now for the standard, the variance. Okay? That is how to compute for the variance using those working equation. Now, what about if we are interested with the standard deviation? Of course, the standard deviation is the same as the symbol. Okay? It is actually the square root of the variance raised to the second power. And so in that case, that is the same as the square root of what is our variance? 1.33. 1.33. And so what is the standard deviation now? Standard deviation, or that is the same as the symbol. Okay? That is actually equal to what? We have now 1.15. I'm sorry, it's very noisy. Okay? So that is how to compute for the mean, the variance, and standard deviation. Okay? So standard deviation. Now notice that what we did in the process, when we calculated the standard deviation, the variance, and the mean, it is a very long process. It's very complicated when you look at it. Why? Because it is in a horizontal manner. So one way to compute these things, variance, mean, and standard deviation, is of course making use of the table. And that is what we are going to look into. How we are going to present our data and then compute these things using table. Because as I said, it's better to compute these things guided by the table. Okay, so let's see, continue. Now, notice that when we are going to solve for the mean, variance, and standard deviation, now what we try to present to you while math is a long method or a horizontal method using strictly the working equation, following strictly the working equation that we have in here. And as I said, it is very taxing and of course complicated. So what are we going to do? We are going to put this one into table. Okay, into table. And how do we solve? How do we use the table? The table is actually one way to guide you. Okay, it is one way to guide you how to compute the mean, variance, and standard deviation. Notice that we have the same problem. In our same problem, it says in here, in a weather forecast, they gathered this data. The Weather Bureau gathered this data that there are a number of typhoons per month. At 1 month, in a month, there could be a possible 0 typhoon. In a month, there could be only one typhoon, 2 typhoon, 3 typhoon, and 4 typhoons. Okay, 4 typhoons. So that is the gathered data. Meaning to say, siguro, the maximum number of typhoons really gathered in a month is 4. Okay? But what is their probability? Of course, the probability of having this number of typhoons in a month are given also. So when there is a zero typhoon in a month, the probability is 0.15 or 15%. That is the same as 0.35 or 35% when we have one typhoon in a month. And so that if we have 2 typhoons in a month, the probability is 30%. If we have 3 typhoons in a month, the probability is only 10%. And 4 typhoons in a month, the probability is also 10%. It is, of course, lesser probability. Okay? You can just imagine that if we have 4 typhoons in a month, meaning to say, your cloth that you wash will have a problem. Why? Because upon drying of the cloth, there will again another typhoon that will most probably make a problem in your clothing when you're going to look into the impact of these typhoons. Okay, in our life. Okay, not only that one in farming. Okay, it's a problem that when we have a typhoon, or shall we say 3 typhoons in a month, it will affect the farmers, okay? The harvest of the farmer, the planting season of the farmer, okay? So, ayan. Now, anyway, let's try to have, the question in here is, what is the average mean of number of typhoons in a month, okay? As we have done that one. Now, we use the table. We use the table to compute those mean and variance. And mind you, how do we design our table? This table. The design of this table is actually based from our working equation. Okay? Based from our working equation. So notice that if I have a mean in here, definitely I have a variable x and I have its probability. And this variable and probability is presented into this table. So this is our variable, number of typhoons, its corresponding probability, this one. Okay? So again, it says in here, when we are going to get the mean, we are going to multiply this one, and then after that one, we get the sum of this product. And so what are we going to do? That is the same as we make the third column. What is our third column? The 2, the variable and then the probability. The product of the variable and then the probability. And so that is the same as multiplying this one. So when we multiply these things, that is the same as 0. 0 multiplied by 0.15, that is the same as 0.0. Okay? What about this one? 1 multiplied by 0.35, that is the same as 0.35. Okay? Okay, again, we multiply this one, 0.30 multiplied by 2. Of course, it will give you 0.60. Okay? And so how about this one? It will give you 0.60 0.30. And 4 multiplied by 0.10, it will give you 0.40. Okay? So that is the product. These are the product. Okay? These are the product as stated by this working equation in the mean. So it says in here, when we are going to get the mean, the product, only product in here, this one, we are going to sum them up. I-add natin lahat. So that is the same as when we get now the mean, we will be adding all this one. Okay? So ayan, 5 plus 0 plus 0 plus 0, that is the same as 5. 4 plus 3, that is 7 multiplied by this one. 13 multiplied by this one, 16. Okay, so 6. Carry 1. Okay, so 1, 1, 1. So 1.65. So that is the mean. So that is the mean, as you can see with this one. Next is, of course, we are going now to look into the variance. How do we compute for the variance? So for the variance, notice that in the working equation of the variance, first, we get first operation, we get the mean. We get the individual variable minus the mean and minus the mean. So that is the same as, we have that one as to be your fourth column. Fourth column, variable minus the mean, computed mean. And so that is the same as saying x, your x is 0. So that is the same as 0 minus the mean, that is 1.65. Okay? 1.65. That is the same as 1 multiplied minus the mean. So 1 minus the mean, 1.65. Okay? Still, 2 minus the mean, 2 minus the mean, 2 minus the mean, which is 1.65. Then next, 3, that is minus the mean, that is the same as 3 minus the mean, which is 1.65, followed by 4 minus the mean, which is 1.65. So that is the working equation. Definitely, we will be getting immediately the result. So the difference. So what is the difference of this one? That is negative 1.65. Okay? The difference. What is the difference? That is the same as negative 0.65. Okay? 0.65. And what about this one? What about this one? 2 minus 1.65. 0.35. 0.35. What about this one? That is the same as equal to 1.35. And what about this one? 2 point, that is 2.35. 2.35. So that is the same as using the table. Okay? So of course, when we are going to have this one, mind you, have all your calculator so that you will be guided by your calculator also. Okay? Ayan. Use your calculator. Okay? Always make use of your calculator. Now, after having now this one as according to your difference of variable minus mean, which is this one, it says in here, the result in here is you have to raise to the second power. Okay? So what is the result? Negative 1.65. Okay? Negative 1.65. Raised to the second power. Raised to the second power. Okay? Then after that one, what will be the result? It will give you, that is the same as, oh yeah, I'm sorry. Okay, 1.65 raised to the second power. So result, it will give you, that is the same as 2.7225. Okay, 7225. Okay, this one is negative. Okay, so that is the same as what about that one? Negative 0.0 0.65 raised to the second power, it will give you a result of what? That is 0, okay? 0.4225, okay? Now again, that is the same as 0.35, this one, 0.35 raised to the second power, that is the same raised to the second power. So what would be the result? It will give you a result of what? 0, okay? 0.1225, okay? Yan. Now the next one is, of course, we have in here this result that is the same as 1.35 raised to the second power result. It will give you you will have a result of 1.8225. And of course, that is the same as the next one. In here, that is the same as 2.35 raised to the second power. It will give you a result of what? Okay, 5.5225. Okay? So these are the result. Meaning to say, this result are actually the squared result of x minus the mean, or variable minus the computed mean. Then, so after that one, raise it to the second power. Now, what is the next? Still, we are talking of the variance. What is the next? It says in here that when we have already the result of that one, and we are done raising it to the second power, the result of the whole is to be multiplied by its corresponding probability. Okay? By its corresponding probability. So meaning, this result is to be multiplied by its corresponding probability. So that is the same as saying now, we have in here 2.7225 multiplied by its corresponding probability, 0.15. So it will give you a result of what? It will give you a result of 0.4083. Okay? 83775. Okay, 8375. Of course, we will always be rounding them off. Okay? We will always rounding them off. Another one is this one, 0.4225 multiplied by its corresponding probability, 0.35. It will give you a result of that is the same as, can we round it off immediately? Mag-round off na tayo. Can we round it off? This is the same as 0.41. Okay? 0.41. Okay? Another one in here is, what about this one? 0.15. Okay? 0.15. The next one is, of course, from this one. No? So, 0.1225 multiplied by its corresponding probability, that is the same as 0.30. It will give you now a result of 0.37. Now, what about this one? Raised to the second rate multiplied by its corresponding probability, 1.8225 multiplied by its corresponding probability, that is the same as 0.1. So it will give you a result of what? Okay, so it will give you 0.18. Okay, 0.18. And what about this one? Multiplied by this one, it will give you a result of 0.55. Now, we are already done with the individual parts of the variance. We are done with this, which is this result. Okay? We are done with this, which is this result. And we are done with multiplying this one. This one is the result. And so the next thing now that we're going to do is we're going to look into the variance. And what is the variance? It says in here, all the result of this one will be sum up. You total them. That is the same as saying we are going now to get the variance. When we are going to get the variance, we will all add this one. We just add this result. That is the same as saying now. That is the same as saying now. That is 1 plus 6 plus 7, 13, 21. That is 26. Okay, 26. That is 2 plus 4. That is 6, 7, 8, 9, 10. 11, 12, 13, 14, 16. Okay? 16. And so that is the same as you will notice, it will give you a result that is the same as 1.66. Okay? 1.66, the variance is 1.66. Now as you can see, with our long method a while ago, we tried to have a shortcut. Okay? We rounded off. Everything was rounded off, and so there is a discrepancy with what we computed, which is 1.33. Okay, 1.33. Now, after that one, we are now ready to get the standard deviation. So the standard deviation is represented by the symbol that is the same as the square root of 1.66. And so it will give you now what is the square root of 1.66. It will give you now a result which is 1.28. Okay, 1.29 rounded. Okay, 1.29. So the square root of 1.66 is the same as 1.29. And so this is the standard deviation. Okay? I hope you understand the way how to compute the standard deviation, the variance, and the mean. We have two comparisons. We compare the two. Okay, the horizontal one and of course the use of the table. But of course, what we will be using is in computing the mean, variance, and standard deviation is we follow the table. Why? It is because in the presentation of data, in your chapter 4 in your research, you follow this one. You follow the table. May I have this opportunity that upon watching this one, I hope you understand the lesson, and may I encourage you to subscribe this one so that would there be a next lesson, you can be notified immediately. Okay, so subscribe and like. Thank you.